All right, so in this video, we're going to go through sample question 72 from the Society of Actuaries ExamP list of sample questions. The question reads, an investment account earns an annual interest rate R that follows a uniform distribution on the interval 0.04 to 0.08. The value of 10,000 the value of a 10,000 initial investment in this account after 1 year is given by V equals 10,000 e to the R. Let f be the cumulative distribution function of V. We need to determine f of V for values of V that satisfy 0, less than f of V, less than 1. Right? So this is an example of a univariate transformation problem. I talk a little more in depth about univariate transformations in my video on question number 71. So if you have trouble with this topic, I recommend that. It's a pretty easy question that really kind of does a good job explaining what this is about, okay? But what I kind of talk about is, listen, we have two functions. They each have a CDF and a PDF, right? And we want ways of going from one to the other. So let's see what they give us. Let's see what we need, all right? Let's say R is function 1 and V is function 2, right? So these will be V's stuff and this will be R's stuff. Now, we're given information about R. We're told it's uniform over a specific interval. So it's a continuous uniform random variable. We should know both of these things. That's memorized, right? And we need to find the CDF of V. So what's going to be the easiest way to do that? Well, we can use the CDF of R here and then just convert it to V. So what is the CDF of R? The CDF of any continuous uniform distribution is always going to be the following: x minus a, where a is the lower bound, over b minus a, where b is the upper bound. So x minus 0.04 over 0.04 is our CDF of R. Okay, now let's look at building the CDF of V. We need to find the CDF of V, capital F of V should be equal to the probability of V being less than or equal to some specific tiny v, some small v. Now, I know V is equal to 10,000 e raised to the R power, and that is less than some specific V. Now, what I want to do is isolate R. Okay, easy enough. So the probability is just going to be E raised to the R. I'm dividing 10,000 on both sides, and I get V over 10,000. And then in order to get rid of this E, I need to take a natural logarithm to both sides. So this is going to be the probability of R, and then ln V over 10,000 right there. Okay, so now that we found the CDF of V in terms of R, I can now just plug this in, right? So the I can just write this as the natural logarithm of V over 10,000 minus 0.04 over 0.04. Now that doesn't match up with any of our answer choices, so I can rework this, okay? Now, 1 over 0.04 is simply just 25. So you could rewrite this whole thing as just having a coefficient of 25, and then in parentheses, a natural log of V over 10,000 minus 0.04. And that does line up with a particular answer choice E. All right, so let's just review, right? Univariate transformation, two functions, each function has two items, a CDF and a PDF. We're given typically one of those things of one function and asked to find one of those things for the other function. Here, we're actually lucky. We are given that R is uniform. So we should already have the formulas for a CDF and PDF memorized. Some places might say, just memorize the PDF, you can integrate, because it's better to really understand what's going on than just to memorize a bunch of stuff. And typically I would agree with that. However, I don't think memorizing the CDF also is a lot, right? This isn't like ExamFM where you could memorize one equation and then convert it to like 5 other ones, right? This is just an extra thing, right? And for me, it saves a lot of time. For you, it might not. For you, you might just have the PDF memorized, and from there you can integrate and then do this conversion, right? That might be quicker for you. But I highly, highly recommend here, memorize the CDF and PDF for all continuous distributions that you should have memorized: exponential, uniform, normal. Okay. If there are any questions, throw something down in the comments. I'll answer to the best of my abilities. If this video helped you out, hit the like button, subscribe. That really helps me out. But yeah, other than that, good luck. Oh, yes, and if you're looking for more questions done out like this, I have a playlist. Should mention that. But yes, other than that, thanks for watching.